A, B, and C in terms of A and B. So the first thing that you do, you draw the diagrams to represent this part, draw another diagram to represent this part. So for this one, we're going to have this particular diagram as its a representation. The angle there is 28 degrees, and we know that for sine is opposite over hypotenuse, and if it's just A, we know it's A over 1. Therefore the opposite side is opposite to the angle, therefore this is the side that is A, and the hypotenuse becomes 1. And we know that to find this missing part here, we're going to have to use the theorem of Pythagoras. And if you use the theorem of Pythagoras, you're going to find this side to be a 1 minus a squared. So this is the first diagram. The second diagram you're going to have to use is for this one, for cos, which is going to become the angle of 32 degrees, and the opposite, this one is cos, therefore it's going to become adjacent over hypotenuse. Now this side is adjacent to the angle, this one is opposite. And if this is the information we have, when we use again the theorem of Pythagoras, we're going to find the opposite side to be b minus, no, it's going to become 1 minus b squared. It's going to become root of 1 minus b squared. It's going to become this side. Now that we have the two diagrams, then we can start solving the problems in terms of A and B. So the first one, now we are dealing with the answers. You have your diagrams to assist you into solving the problems. So the first one is cos of 28. So cos of 28, cos of 28, we go to the diagram that has 28 as a degree. Then we're going to say, okay, cos of 28 degrees is the same as, here is 28 degrees, cos is adjacent over hypotenuse, therefore is the same as root of 1 minus a squared all over 1. We are done with this one. The second one, for B, we have cos of 64 degrees, therefore cos of 64 degrees, therefore this one we can see that it does not relate with any of these particular diagrams, therefore we can now simplify the angle and say, okay, but we can make a relationship to say 64 is the same as 32 divided by 2, therefore this one can be represented like 2 into 32. So according to the rules of trigonometry, we can identify this one as a double angle identity. So we know that cos has 3 double angle identities. The first identity becomes, it's cos squared of theta minus sine squared of theta. The second one is 2 cos squared of theta minus 1, and the last one is 1 minus 2 sine squared of theta. Now instead of theta, in this case we have 32, therefore we can choose one of these and represent this one with that. So we can pick this one for an instance and say, okay, we have 2 cos squared of, the angle is 32 minus 1. And we know that cos of 32 is equal to b, therefore we're going to have 2 into b, then it was squared, then we put square there, minus 1. Simplify this one, we're going to have 2b squared minus 1. We've solved the second part of the problem. Now the last one, which is C, this one we have sine of 4 degrees. So for sine of 4 degrees, we can see that this one also does not relate with much that is given there in the information, but we can work it out to say, but 32 minus 28 gives us 4. So let's simplify this one using compound angles. Then we're going to have sine of 32 degrees minus 28 degrees. And we know that according to compound angles, the expansion of sine is going to be sine of 32 cos of 28 degrees, we keep the sine the same, minus sine of 28 degrees cos of 32 degrees. Now let's simplify this one even further to say, okay, what is sine of 32? We come to the one that is 32. Sine is opposite over hypotenuse, therefore we're going to say it's root of 1 minus b squared. And then what is cos of 28? Cos of 28 is adjacent over that one, which is root of 1 minus a squared. Comrades, this is a, man. Let me just fix it. It becomes 1 minus a squared, and then minus Sine of 28 is A times cos of 32, which is B. Therefore, I think the simplest form of this one, not the simplest form, but I'm going to stop on this step where I just multiply this one. Then it's going to become 1 minus b squared times 1 minus a squared minus ab. Okay, you can go further when plus you're a genius, but I'll stop here. So we actually solved these problems in terms of A and B.